Let me go back real quick here
I
for
had that too,
for
and then I
Taya,
went and solved it.
since
Yeah, I
she's not
did.
And I
here.
got x equals 20, which doesn't make any sense because then the area will be.
Oh, wait a second.
That's what I was confused. I did.
Yeah, you know that X is. So when I just took the derivative.
Eli, there's a
of the
discussion
area-
between Sadie and Enrique. We're gonna just listen. Go ahead.
When I took the derivative of the area, then I got another function, and in order to solve that, I had to multiply by something for which I had to. Did you take the derivative of it?
Yeah, I did.
Yeah, and then so then you have square root of 20 squared minus x squared on the bottom, right?
Yes.
And so then when you multiply by that,
Wait, I have the 3 root 2, not the square root. Because if you take the derivative, you bring the 1/2.
yeah,
and then
1/2.
You have to subtract 1 from 1/2. Well, I guess that would be.
That's negative 1/2, right?
Maybe that's probably.
Yeah, that's probably what you did. And then when you multiply through, you know that x can't be greater than or equal to 20, but you already
Yeah.
knew that because of the domain.
Yeah.
So it's okay. And then when you solve it out, you get x equals 10 root 2.
Well, I did that though with trick.
Well, I think that's the problem when you had this, if you did the derivative and
Yeah.
that power, then
Yeah.
that will fix it.
Well, because I was like, okay, that doesn't make sense. And then I plugged in a bunch of different values.
Eli, for yours.
14 was the biggest. And then
Just
I
to
just
start
gave
you.
up and you just like, well, you know what? I know if it's a rectangle and if we split it in half, that's gonna be a 45, 47, 90. So then I can just use trig to find out what the area is.
But
Eli had a question for 12, so I just kind of put it on there.
Well, if you know that the hypotenuse has to be 20 squared, then that gives you a set value for the size of the rectangle. The rectangle can't, diagonal has to be.
Oh, that's true. Okay.
So
yeah.
It's already.
And you have the angles.
Yeah, so I just solved it and I got 10 or 2, and I did that, so.
That seems illegal because you didn't use calculus.
Well, okay, I have a whole bunch of calculus here, but it was incorrect, so I crossed it out lightly and then just did it with trig.
Also, it wasn't a calculator problem, so if you had to use your but I mean, that still worked.
No, I didn't actually have to use my calculator for the trig bit. I just, after I got stuck on the calculus part, I plugged up in my calculator to see if that helped me, which it didn't.
But it's a lot, if you just have the one power as negative 1/2, it makes it a lot easier, and then you can just.
Yeah, I don't have to bring up 2 times the square root of 400 minus x squared cubed.
Yeah.
That was very nice.
Multiply
nice
that
derivative.
with the square root, or no, 400 minus x squared squared. Because my final derivative was negative 4x squared times 400 minus x squared. The square root of that over 2.
It's because, yeah, so if you don't have that extra part, then you can just get rid of the square root of 400 minus x squared.
Mhm.
Pretty easy.
Well, I guess I can redo it that way.
Good. Okay. Number 12 is also on board here. So this is the error problem.
I was so stupid on number 12. I did all the right work, and then somehow I plugged it into my calculator. I didn't do it right, and I got the wrong answer.
Not sure what you did. Did you just multiply? I think you just multiplied 50 times 4.
I have no idea what I did. I mean, maybe.
Yeah.
I didn't write it out.
So then it went there.
But all my real answers before I simplified it by approximating or whatever were correct. So I mean, it's incorrect because I multiplied wrong, but it's kind of a stupid error.
Okay, are we done with okay with 12? The only thing that's not here is still the percent error. So all you do is you convert this guy to a percent. So not bad. About 1/10% error on that as we look at it.
I have 2 more questions.
Sure. 8 and 9. Let me just start you off on it here.
8. I don't get. I feel like I did my limit thing wrong. I don't get how. You wrote on my test, you said it goes to 0 or to 1 instead of 0. But I don't get why it goes to 1 instead of 0.
Mhm.
So I don't know if I did it right.
Sure, that's
It is
towards
the
the end,
whole-
right?
I
You
did
this,
the whole learn why thing and all that.
yeah. So you got to this far, right?
Yeah,
So then
I
you're
did
going,
that all right.
Uh-huh.
And then
sorry, Eli, go ahead if you want to copy it. Ooh, it's warm over here. Okay,
that stuff was all fine. At least you didn't mark any of
Mhm.
it, so.
sure. Then you get to, you start getting to this right here. So you have n going to infinity. And you should have something looks like this right here. 1/1 plus 1/n.
Yeah, and then you can cross out
Okay,
the.
so.
And the infinity, that n is going to infinity, which means 1/n is going to 0. And I can take a look at yours.
Oh, well, I don't have my test with me, but
Okay.
I think what I did is, I think I did it wrong. I put this as the 1/, on the bottom, which made it much more difficult for myself. So I think if I do it the other way.
1/n on the
1
bottom
over n.
makes a lot more easier to handle that because you have that ln function to deal with.
Yeah, that'll probably.
Cool, okay.
And then for 9, I did it in, but I didn't get something that was close to what the square root of 1.1 actually is.
Mhm.
So I. Yeah.
Let's see, formula is good though. F of a, right? Plus the derivative at a, because it's taking the slope and then the difference between the two.
Okay.
So I think once you get these right here, once you establish what a is.
0.1 correct instead of 1.1.
I think
Okay. X is 1.1, therefore the difference between the two is going to be
0.1.
0.1, or 0.1, yeah.
Wait,
So then,
you put in.
you plug in the 1 because that's the closest value we have that's easy enough to get to. So square root of 1 is 1, we know that. And then the 1/2 comes from the derivative at 1 again. And then the difference, the x minus a, is going to be 1.1 minus 1. Go ahead.
I combined, so I had the same formula set, and then I had 1 plus 1/2 times x minus 1. And then I put that into the fraction, and then, okay, that's what.
You still have the x in there.
Yeah, I
As
put,
opposed to,
I put the x at top, and then I added the 1 in, so I have 1 plus x, 2. And then,
top.
so if I had plugged in a 1.1,
The minus
I would have gotten
the minus
2.1.
1 looked off.
then
Okay, no, let's see.
I would have gone at 2.1 over 2, and that would have done. Okay, so that's what I did wrong, is x is not, x is equal to 1.1, not 0.1, so that's was a conceptual error on my part.
Cool, no problem. Challenge, okay. Eli, go ahead.
I have a question on this one just because I got that answer, but I only got 3 out of 4. So I was wondering, is it just because I didn't simplify enough?
Ooh, let me find out. See if I have the test with me. Eli, I don't mind changing that here, yeah, because now Enrique did exactly the same way on those here. So I think you made a calculation error because 2.1 over 2, but actually that is true. 2.1 over 2 is 1.01. So Eli, on that one for number 9, I am going to give you the 4 points for it.
Okay, thank you.
That was my fault there on that one.
Can I see the one for 3?
Number 3?
Yeah, I got all mixed up with all the exponents, the fractional exponents.
Uh-huh.
I learned that simplifying is important. Well, when.
Okay, I think that's dumb. I stopped just at the second step.
Uh-huh. So easiest way to do it is get that denominator to be exactly the same. So multiply top and bottom by x to the 2/3.
Okay.
And the cool thing that happens is x to the 2/3 times x to the 1/3 just gives you a nice x. And from there, simplifying it out gives you a nice thing to deal with at this point.
Okay, I got.
I have a question, which is from the old book, and I can't remember what it was, but when we were doing max and mins and graphing and stuff, you would tell us there was something we had to do where we had to make a line, a number line, you know, and find, I'm not sure whether it was when the particle is moving forward or when the particle, its slope is increasing, and, you know, we would plug in the points into the original function to find whether it's positive or negative. I don't quite remember that from the OpenStax book. And then, but in this test, we had, you know, the motion of the particle. And he said, when is the particle moving forward? And in that instance, we still did the number line and we had the critical points and whatever, and then we would find whether it was positive or negative. But that time we were plugging it into the derivative because moving forward corresponds to positive or negative derivative, right? So,
Yeah.
but before, in the previous chapter, we were using the old book, we had something where we had to do a number line and we were plugging it into the original function. Do you remember what we were finding in that instance? And like, because I mix up those two cases.
Yeah,
And I can't remember what the first one is though.
The only time you plug into the original equation is to get position. You want to know where things have turned.
Like
right?
for F, right?
For F, yeah.
So we
So
would-
derivative will always give you direction. So you want to know direction with derivative.
So forward or backward, right?
Yeah.
What about knowing, well, there was something else though, because we didn't just do forward and backward. Was there something else that we used the number line to find? Or am I just really mixing it up? 'Cause I feel like there was-
Concavity, right? When we took the second derivative, we looked at concavity, but not particle, not movement of a line though. You can take the second derivative of that to look at acceleration. We did that. In the
Oh, yeah,
previous
I
book,
remember
right?
that.
We did acceleration. And so it's slowing down or speeding up.
I feel like there's-
But I don't think we ever plugged in. We can also plug in values. The other way to do it is when you plug in values for position, right? Let's say one is 50, one is 37. You know that it went backwards, right? Because the difference between them would go to the negative
Yeah.
side, but not to just. So you could find it that way as well. With that.
Okay, yeah, but I don't think we did that.
No, we just plugged into derivative because we just wanted a direction.
So there's not another thing that we can use a number line, that we use a number line to find. I thought there was something else other than whether the particle was moving forward, but I'm probably just missing that. I don't know,
Yeah.
is what we did in there in this book too, because the graphing stuff, I didn't see a whole section on graphing like we did in OpenStax.
Yeah, we did the graphing. I did not do that one on this one. It's 4 point. The shape of the graph, 4.3. And we skipped that one because we already covered the graphing section. So 4.3. If you want to take a look at it. And now it's the shape of the graph. It looks like concavity. And
That's right. Yeah.
and
For 5.
the cusp and all the other stuff. I don't know. I don't know what's gonna be on the
I'm
final yet.
sure it will be on the final.
That's what Sadie and Enrico are talking about right here. So it's the,
Yeah.
Do you want to see my shape stuff.
Yes, I'll leave it on there. Yeah, I'd like to see how you do that.
And then I'll turn in this page and then.
But it doesn't have the number line thing on this section, I don't think. I don't see it.
Uh-huh. They don't do that either. Yeah, they have the interval notation, 288. Again, they do the interval stuff.
Oh.
What's
oh,
wrong with these things? Technically, you could put a number line underneath it.
Yeah, it's the same thing.
Uh-huh.
But, okay, yeah. I
See if
just,
you can, yeah, see if you find it in your notes. If you.
yeah, I switched notebooks because I filled with my last one, so I'll have to look back, but
Okay.
I definitely have it in my phone.
I know with that one, we did do acceleration. With the
Maybe
other,
that's what I was
yeah, because you want to know, what is it speeding up or is it slowing down?
Yeah, that's what it
on-
was.
that was
So
on
then
my
you got-
homework, But it wasn't on the test.
Mm-hmm.
So then
Yeah,
what,
it was just direction. So
so what
speeding
do
up.
we plug it into if we're doing?
For acceleration, you'd still plug it into the second derivative. Well, you find the zeros for the second derivative,
Yeah.
right? And so the speeding up process would be negatives or positives.
When the
And
second
then,
and third derivative are, or the first and second derivative are both like in the same spot on the axis, speeding up.
there you go. Yes,
They're on
yeah.
opposite sides of the axis.
Velocity and acceleration. Yeah, same direction. It's speeding up in that
Okay, we
direction.
looked at the graphs.
Yeah,
Mhm.
with
Okay.
those notes.
Does that solve the mystery?
yeah. I'm sort
Okay.
of not, velocity and acceleration, when we talked about them, like, they're both positive or whatever, it's a little bit confusing to me, but
Mm-hmm.
I don't know. But
Let's see,
what my original question is cleared up, so.
Okay. Yeah, but acceleration and velocity, like for the one on the test,
No,
it would have
I'm just
been,
thinking about it and
Mm-hmm.
kind of visualizing that in a car or whatever,
uh-huh.
doesn't, I'm a little bit confused.
No, yeah, don't think of it as a car, only if you have it in drive and then you put it in reverse. That's, I guess you could think of it that way. But technically, it's motion of a particle in space.
But even
Only on a-
motion, like
Uh-huh.
even once I put a thing and it's moving,
Uh-huh.
it doesn't need to be a car, but
Mhm.
something. As soon as I move away from the map, then I'm like, that's a little bit funky.
Mhm.
And I don't quite see the interchange or interface, I guess, between velocity and acceleration.
Sure,
But that's kind of more of a physics thing. I
yeah.
guess.
In
Well, in
fact,
physics, we do have negative velocity.
that's right. I asked Ms.
Yeah, that
Baird,
doesn't make sense.
yeah, I asked Ms. Baird, do you ever look at this? I showed her the graph, and she goes, I don't ever do that.
No.
So it's gonna be theoretical physics.
Well, because we're
It's gonna
doing
be-
trigonometry physics and not calculus physics.
Even in there, you still deal with a lot of real objects. And this one deals with more of just particle in
Theoretical things
space.
that don't
Yeah,
really
so
work how
that's
they
what-
But I
should
don't
be because
think-
they're math.
But the
I'll
fact
have
that,
to look at a calculus-based physics book, just sort of see. I would be curious now, sort of how it works out.
yeah, I don't know if it's necessary. It's not like the fact that it's a particle or a real thing. It's just the idea of having negative velocity or how velocity when they're both positive or one's negative and one's positive. That doesn't, if I can do the work for it, but then when I think about it actually happening to a particle or something real, then it doesn't make sense to me that
Uh-huh.
that would be a thing, but.
Yeah, I almost want to think of it when I do acceleration and velocity at that pace. You almost think about the pull. Which pull in which direction do you have? So if the car is going forward in drive, right? But the acceleration of it is negative, the pull of it is it's going to go to the reverse side and the push on it until velocity stops and starts going the other way, right? It's almost like the wind, as it were,
Our intelligence hits zero.
Yeah.
right? The wind is going in the opposite direction of the car. Car is going velocities forward. The wind pushes it and the wind's
Sailboat with a motor on it.
yeah, maybe that'd be a better analogy.
Yeah,
With the
Okay.
wind pushing it, eventually it was going to push it backwards with that wind. Something like that. Okay, we good there with that? That's not the end of the problem here, but at least sets you up for what you need to plug in. Cool.
I think I can turn in my test questions if you would.
Cool, yeah, I'll collect them in just a bit here if you guys are ready. If not, take the rest of the week, we'll do them on Wednesday of next week. Okay, let's go with it. Let's see, 15 minutes in, let's jam. So this is the study guide for the next exam. I'll give it to you guys here, but I try to be as straightforward as possible. So, and I think I might decrease the questions still. This is kind of my first run at it here. So 5-1, 5-2, 5-3, 5-4, 5-5.
We should have more of the fast chapter.
Which
less
one?
of the slow chapter.
No, because, well,
So for 5-1, and then don't forget Appendix E. Remember we did some homework off of Appendix E? That was
No,
the
I don't
limit
like
stuff.
doing
That was
that.
the sum
That was
values.
actually better than.
I don't want to do
Uh-huh.
sums.
Aw. I do have one that you guys need to do, write in points, find the area of the curve.
Oh, so that's like what we did before where you draw them.
Yeah, you're gonna draw it, you're gonna
No.
put the endpoints on it, right? You're gonna develop what is the right endpoints for it, and then go with it. We're good?
Okay, I
So
can
one-
review that one.
Yes,
You
one
know,
like that.
For the first problem for 5.1, are you gonna give us like for example, like the expression, will that be like x squared, or is it gonna be like a random graph? And are we gonna have to like, because in the book, it
Yeah.
wasn't like something we had done, and we were supposed to like approximate, okay, this is about 5.5, where I'm drawing this.
Oh, no, this one was f of x is the square root of x,
Right,
going from 0 to 4.
yeah, that's
And
what
then-
I'm asking. Will it be one that we have like an example of in our books, or is it gonna be?
I might change it up just a little bit here, but you don't evaluate it, right? You just find the expression
Squared plus 1.
for the given area, right?
It's just, it's completely different from all this other stuff.
Uh-huh.
It's just complete reversal.
It's a, yeah,
I
opposite direction,
blame-
kind of.
I blame antiderivatives for my mistake. Because 3/2 is something that we get at the top.
I'm sorry.
Well, no, this
Oh,
is,
you did do that.
it's
You
my,
added an extra.
Yeah.
I didn't think
Uh-huh.
about
but I
that.
still made it negative.
Yeah,
So it's
you
like,
combined the two
Yeah.
problems, yeah.
I did take these instructions directly from the homework itself, so you should be able to find homework questions that are, the instructions are listed
Is
underneath.
the number of problems that are gonna deal with that?
Yeah, uh-huh. So I have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I thought maybe a little too much. I may reduce it down to somewhere between 15 and 18
And
or
it's a
something like that.
take-home test though.
It is a
so-
take home, yeah. I don't want it too, I don't want you guys
Those are very
working.
long sitting.
Take out the 5.1 value of the sums.
Oh, yeah?
Those ones are boring and no fun.
no, take out find the limit of that.
No, final limit is, well, yeah, final limit's better.
So,
I don't want to plug in numbers. I don't,
but
Well,
isn't that
if it's-
finding the limit plugging in numbers? Find the sum. Wait,
No,
no,
find the
value
limit's
of the
not-
sum.
Final limit was just summation.
See, but find the limit is hard, because then you have to like actually do the summation.
and you
where it's
actually have to
like-
think about it.
Like,
Yeah.
to find
Oh,
the
yeah.
value of the sum, you can just kind of like.
5, done.
But
Yeah.
you should
and
make that,
say you
Computation.
messed up on it.
if you're gonna do the final value of the sum, it would be nice if either it's easy problems or it's in the calculator section, so we don't have to do like a ton of multiplication on the side.
Find the sum of.
Or not, wait, no, I guess it's
Up
addition.
to,
But
Yeah,
if
it's gonna be
But
addition.
depending on the function, like if the
Uh-huh.
function involves a lot of multiplication,
Mm-hmm.
if it's like x cubed plus 3x, and then you have to get.
No, it
add.
won't be that. No, I'm not gonna make it that long, no. Possibly maybe like a square term in there, but that's about it.
I'm gonna
Not,
throw,
not
sum
beyond
up
that.
all the numbers to 100 data.
That's right, Frederick Austin. I could, just maybe. Okay, let's jam. So there's that. We're good? It's, again, I try to be straightforward. Take a look at your homework before you do the test and at least the sections that are similar to it. Okay, last time we did 5.5, we did the definite integral.
Oh, yeah, so is the test still gonna be due week Wednesday?
Yes, uh-huh.
Okay.
Yeah, if you guys can come in with the test in hand on Wednesday.
Oh, you want us to turn it in live?
Yeah, uh-huh. So, yeah, we can do it and then turn it in on Wednesday. Okay, we're good there.
And then
So,
do you want us to turn in our homework online again or in person?
let's see. If you guys can turn the homework online, but the test in person.
Yeah.
That'd be good. Good. Okay, next thing is chapter 6, so 5.5, homework wise, do you guys want me to send you guys the solutions to 5.5?
Yeah, those were
That would
very
be
helpful.
nice. Yeah, okay.
There were problems that I got stuck on and then I didn't have benefit of asking, because I was a bad boy and didn't keep up with my homework.
Uh-huh.
And so I haven't kept up with this homework. So it was useful, just for like, even if I, like, just getting me started on some of the problems.
Mhm.
Yeah,
Like
not,
seeing where they went, not even like all
yeah.
Yeah,
the way. That was useful.
okay, sounds
Or
good. I will
sometimes if you
send
did
it.
it and like got the right answer, but you wanted to see, well, is there how did they do it? Or should I plan on doing it a
They
different
skipped
way?
like 7 of the steps
Or
that you
like
did.
the
Yeah.
more,
Okay.
or the more conceptual problems, where like they don't put an answer in the back of the book, because it's like, you gotta prove this.
Uh-huh,
And then I always get tripped up on those.
okay. Gotcha.
That would be awesome.
Homework solutions. Test. Okay. We're good there. Now let's jump to starting of chapter 6. Oh man, awesome stuff. Let's go with, so this is technically, they're in the application of derivative section. Oh, sorry, application of antiderivatives. That's where we're at now.
Wait, so you say technically,
It's the application of antiderivatives. That's where we're in. It's the last, last section, or last chapter. So we have area. We're gonna jump to volume after this. And then we're gonna look at average value of functions and then work from a calculus perspective.
work,
So would we, is one way to find the area of the two,
So let's go with it here. Yeah. So notice we actually go below the x-axis. That is interesting. So
could you just elevate them?
you could elevate them, but no need to, unless you're trying to do that for, let's see. Maybe, but no, we don't want to elevate them. We just want to get the difference between them. Right, so if this is like, let's say this is a -3 down here, right? And that's a 5 up here, right? So the whole stretch would be 8, correct, between the two? So if we just do this, don't we have our 8 that we need? So really it's just a subtraction. That's all we need. It's just the value on top. In fact, you're gonna hear me do this a lot. It's gonna be top minus bottom. Just make sure that you know which one's the top, which one's the bottom. The rest of your calculations are gonna go wrong. Are we good? With that, where is my cheat sheet? I just have my paper here. Okay, so if that's true, and we're just doing this right here, everybody okay with? Look at that. There it is again. It's going to be just a subtraction between the two, right?
What are the asterisks for?
Asterisk means I can take any.
I heard them seeing that in the home.
It means I can take any slice in, let me go back over here, real quick here. It's this little piece right here. Okay, it's any slice in this rectangle I can take. Not necessarily the right, not necessarily the left, not necessarily the middle either. I can take it anywhere in that slice, because as the slices get smaller and smaller and smaller and smaller, they eventually will still model that whole entire set of area. Good. So 7.1, 6.1 area between curves. I guess what we got to do is, can you guys convert this into the antiderivative formula? What do you guys say? What's over here? So this is the summation formula. I'm going to take f of x pieces I'm gonna slice them from 1 all the way to n, and I'm gonna take the n all the way out to infinity.
Wait, so where you want us to write it as an integration?
So the area between curves would be the antiderivative equivalent of this guy. I'll start you guys off. I'll put a equals.
I would teach them that. I definitely know what you're.
Oh,
We still have a limit in there.
we should have a limit in here, yeah, instead of just, we should bind this here. So how about this, from x is equal to a to x is equal to b? How about that? I'll go from a to b. Everybody okay with, let's see, going from a to b on here?
Yeah, and then we just put the functions, right?
Yeah, and then it's really just the difference between them, right? So in brackets here, we're gonna go f of x minus g of x, and then go dx. So really, if we think about this here, all the stuff that we've been doing so far, whenever we took the area under the curve, right? It's just g was 0.
Wow.
That was just a special case of all the stuff we've been doing so far. And that was it. Okay, cool. So let's jam.
So is that how we could do like a bottle or something with things going?
Yeah, so the Coke bottle, that would be 0 because we want to get that Coke bottle to look like that, right? But then we also want to do other stuff. So let's take a look at other stuff, especially with, we'll see. Oh, do you guys see that or no? Do it. Nope. Okay, let me bring this down over here. There it is. Eli, we're gonna bring you down to a different spot on the screen. Okay, let's jam. We got 6 problems that we need to get through in a half an hour, so about 5 minutes per problem. I think we can do it. We're cool enough like that. So find the area of the region bounded above by y is equal to x to the e to the x, bounded below by x, y is equal to x. And we're gonna go from 0 to 1. Now, it takes, on the homework, if you want to, please graph these, because seeing the visual on it helps tremendously to sort of see what you're dealing with here. Okay, so if we want to graph them, maybe as some graph here, I'm going to do a quick one here, I think. Yeah. E to the x. I remember e to the x. It's an exponential function, right? It goes through 0, 1, and it goes like this. And then this guy is y is equal to x. That is an identity function. It goes like this, right? So I'm looking for something kind of looks like this. From 0, and I'm going to just arbitrarily put 1 over here. So I have this little shade right here, if that makes sense. Let's jam. This is the easy one. Go for it. So the area underneath the curve is going to be from 0 to 1. The top function is e to the x minus the bottom function, which is just x itself, dx. Can we do that one? That should go sort of quickly.
So we just take the derivative or the antiderivative.
Each of those. Now notice we got a subtraction in our hands too, right? So then you could take it as one piece, or if it gets much more complicated, we can separate them out into 2 pieces. That's fine. I think for this one, this was easy enough to do. So how about e to the x? We good there? Let's see. Minus sign still. X squared over 2. Bracket. And evaluated. Let's see if they do that. Yeah. See, they have this one. I like brackets because it tells me which ones to do when. But But let me do it this way here. Let's just do it the way the book does it so we don't get confused here. I'm gonna go like this right here. So evaluation says the whole entire expression there is being evaluated. As I'm looking through here, yeah, they do that. Okay, cool. I'm glad they do that here. So you can write it like this is fine. What they do also sometimes they write it like this as well. So that's perfect. So all yours to end up, and let's jam to the next one if need be here. So notice this gets a little bit more complicated because now we're going to do this right here, right? We have a subtraction between the two. Plug a 1 into that, makes e to the 1 minus, what is that, 1/2? And then plug in a e to the 0, gets us that. And Kate already said it here, e to the 0 is 1. E minus 3/2 or e minus 1.5. Either one is just fine. We good? Not bad. That's cool, but it allows us now to go underneath the x-axis if we like. It allows us to have two different functions that we can see the difference between the two. And why is that important? Aha, I'll have to wait till after vacation.
Oh.
Love it.
Cliffhanger.
Love the cliffhangers. Okay. I did copy and paste from each one of these just so you see that's what we're looking at right here. So e to the x and then 1. This is a true picture here. Okay, all yours, go. 1 to try. If you need to graph it, that's fine. Go for it. Then,
Will we be able to graph them on our calculators on the text?
on the test.
Or
No, you
Yeah,
have
I'll
to
have
graph a
to
whole
see.
hyperbolic function and the second hyperbolic
Why did
function
you
and
just
find the
drop it
area.
necessarily?
See it?
What's the value of dropping it?
Oh, just to visually see it, that's all. Especially when you're just beginning to use this.
Well, I mean, like,
It's
we can visualize x squared, okay, and 2x minus x squared. It's a little bit harder, but still
Mhm.
not without, I mean, you could kind of do it in a small domain.
So let's see, x squared usually goes like this. Haha, that's funny. Usually, no, it always goes like that.
And we're not going to from a specific point to a specific point, because
Yeah, do we have a?
we're going to have to find the points ourselves.
Yes, that is the fun part here. So there's an area that's bounded. Now I got to figure where that bounding takes place.
Can we do that by saying them to each other?
Oh, absolutely. So let's see, I got this one. This one, you guys remember from algebra, it'd be like this. So do you guys have, let's see, can we all already see that we have zeros at 0, 0? And 2, 0. Are we good there? Talk to me, if that makes sense. If you set this one equal to 0, we pull out an x. And we have this on our hands, right? We got a 0 at 0. We have a 0 also at 2. It's a parabola facing down as well. We good? Kate, talk to me. We good?
Yeah.
That makes sense? So then I have something that looks like this. Where is a bounded area? It is right here. Is that right? Here's your bounded area. All the other areas are not bounded. So now the question is, what is this guy right here? And Enrique says, just set them equal to each other. Let's go with that. Absolutely. When does x squared equal 2x minus x squared? When does that happen? Let's see, set equal to 0, I guess. Is that right? I'm going to subtract an x squared from both sides here. X is 2x minus 2x squared. Nice. Factor. 2 gets to go out, x gets to go out, x minus, or 1 minus x, I guess. Is that right? Awesome. What do we know? That guy is a 1. That's what I just found out. So my graph is kind of skewed a little bit here. It should have been more like in the middle between 1 and 2. All right, now the top one is, which one's the top function? Which one's the bottom function?
2x minus x squared is the top function.
Perfect. So, oh man, this gets a little complicated. Notice what we're going. We're going from 0 to 1. True. And we have the top function, which is 2x minus x squared, right? Minus, oh boy, minus what's the bottom function? And all that dx. So hold on, I got 3 things on my hands, whole bunch of minus signs between them. This I don't like. Could I simplify the stuff inside this, the antiderivative?
Before we plug things in.
Before we take the antiderivative.
Yeah.
Absolutely. That's just, it's going to be the same function anyways here. So if I simplify, I like this a lot better. So 2x minus 2x squared.
Would you ever use brackets within parentheses, or is it always brackets on, like, parentheses inside of brackets?
Customary, it's always brackets on the outside.
Mhm.
But have I seen brackets on the inside of parentheses? I have, yeah.
Like, what happens if it's in parentheses, brackets, more parentheses? Like, it's big enough where you need something other than brackets and parentheses.
Why would you do the problem?
No,
You
we
do the ones that go like this, right?
Yeah, the wiggly ones.
Oh, yeah.
no, we don't use squigglies for
Because those mean something else.
yeah, those means other things here. So it's brackets and parentheses for operations, for order operations. And
So
we
would
can
you alternate if you had a big enough problem, or would you just stick with brackets at some point or parentheses at some point?
stick with parentheses the most amount of the way too. We don't,
Because
brackets
I
should be
always
the
use
outside.
parentheses before you actually.
Mhm.
I just had a lot of parentheses, which not the
Don't
best.
Occam's razor.
All right. Are we done yet?
More parentheses, the better. Just fill your page with parentheses.
Let's see, I have 2x squared over 2.
Yeah, and then it's 2x cubed.
2x squared over 2 minus 2x cubed over 3, bracket, going from 1 to 0, and then this could be reduced out, right? This little 2 here and that 2, make it a little bit more simpler. It'll just be x squared minus 2x cubed over 3 before we start putting in the values. Oh, and again, I like zeros a lot.
So the 0 does nothing. So it's just 1.
Minus 2/3, is that right?
Yeah.
And if some students do, they put in a little 0 right in here just to say that, yes, I did plug it in. But essentially, 1 minus 2/3 is just a third.
Yep.
For our answer. Quick question here, just to make it even more simpler, could I have just taken out the 2's before even starting this problem completely? Absolutely, it's a constant, right? It's a constant, I can take them out. So I could have actually even taken out that 2 before even doing the problem itself. Cool. So all these different variations you guys have, we're good? So just because one person does it different may not be exactly the same. Okay, now at this point, now we're gonna probably have to get a calculator. So example 3, I need to know that right there.
Oh. Cool.
Is Christopher excited?
Overflowing.
there. I think I got it now. The way I wanted it. See it? There it is. Fancy now. Okay. Oh boy. Okay.
If you shake its face long enough, like fast enough, does it glitch out? Well,
When you guys were on Zoom, we always hid your videos.
oh,
I don't know why. Well, I guess there was a lot of stuff on the slides.
I'm not.
I don't know what
That's
you
Eli.
Eli's special.
Wow.
Okay.
I see how it is.
I really have a tough one here. I don't know which one's top, which one's bottom.
You can graph them. Are we supposed to be able to do it without graphing?
We probably know at this point, we should probably graph it. See what is there. Oh, we might get a graphing. I will just even solve it. Let's see. Okay.
What? No.
So what'd you guys get for the top, the first one here?
I think I did it.
So on your calculator, graph this guy here. I don't know what this looks like.
Actually, I don't even know because my calculator doesn't do different colors.
The first
Ah.
one's the
Oh,
top
actually,
one, I think.
The
Yeah.
first one is the top one.
Okay, does it go
I have
like,
color on my calculator.
okay. Does it go like lit, like this or something like that, or what?
Yeah.
It goes like kind of like down and then moves us. for the
Okay.
second- for the
Yeah,
Second one?
It's a parabola with a
Second one.
tumor.
Second one does like this and then comes up like that.
Well, yeah, I can do trace.
The-
Eli, you doing good there?
The
Are you able to graph it as well?
zero is more, it's almost like it looks like a straight line kind of.
Sorry, flip it around, let me see.
So that's the, and then I can find lower limit
Boom,
and do that
that,
zero.
and,
Oh, hey, yeah, you can.
It's
do
pretty
Okay.
similar to what you do.
okay. It's almost off-centered a little bit, or no? It doesn't look like a parabola. It's almost like a
Yeah.
slightly oblong.
Yeah.
It looks
It looks like a parabola with a tumor.
Okay, something like that, yeah.
You
Okay.
punch a parabola.
I got
I
this.
got it now.
Wait, Mr. Ardia,
Oh, hey,
Uh-huh.
I can find it
are we
bounded.
allowed to use our calculator?
Bounded
For,
area
yes,
might not
at this
work
point, you
as
probably
expected in
would not be able to do without it.
complex format. So,
So do we need to set them equal again? Or?
Yes, that's right. Set them equal again. Oh boy, here it is. So x over the square root of,
How do you
Calculate and then you want the,
do it yet?
no, not that's further.
Yeah. But I did that and
Find the low, you find the lower limit, and press enter
0.785.
once you have it, it's on zero, and then upper limit. and then
Don't
press
think
enter again,
so.
And then we'll do it.
2 point something or other, maybe.
Yeah, see your
Let's
upper
see.
limit? Yeah,
oh,
upper
my
limit.
calculator says, although I do have it in complex number form. It says
Oh, okay.
Well, It,
so-
it won't, it's not doing it for both functions, it's not doing. It's being annoying,
it's being,
now it won't turn off, okay, no, I don't want that. Ah, it won't get there, it won't go away, in my area. Clear.
Okay, so we could do, Kate, I kind of steered you in a certain direction here. So we got to set these guys equal to each other, right?
Yeah.
But don't we already have a graph in front of us?
Oh, wait,
Cool.
so do we want to?
Can we find some intersection point right over here? And does it look like 0, 0 is the other one or no?
Yeah, it's 0, 0.
Okay, 0, 0 is the other one.
Something I did just.
Intersect.
Intersect, so underneath calc,
First curve,
yes.
is that the
Second,
upper curve? or
Uh-huh.
is that just-
it doesn't matter. If you had more than 2 curves on there, that's when it matters. But if you have only y1 and y2, then you just go click enter, enter, enter. And then get close to the, yeah, just get close to that answer. And you'll find out if you're at the halfway point
I don't
between,
want that.
what did you get?
Not bad number.
Oh, bad number.
It's,
What's the
well,
bad
it says x equals 1.1807757.
Oh,
Y
how
equals
fun.
0.76-ish.
Okay, so I'm gonna go,
I want it to be one.
sure, sure. Okay, I help you.
wait, what?
Oh, wait, second count?
Mm-hmm.
I can't get it to go
And
away.
then number
I
five.
hit the second calculator.
The This is what my calculator is telling me.
First curve, yes. Click enter.
Why would it go away?
Oh, just asking for the first curve. Second curve, click enter. And then when you guess, you want to get a little closer to there.
It won't go away. Turn off the
You're
computer.
getting there, yeah, getting there, getting there, getting there.
There or above
A
it?
little above. Yeah, I just want to get to the close to intersection point. About right there is cool. It's close to the intersection point. Click. 1.18 is what you want.
It's right here or right there?
Oh, yeah, that's the intersection you want, because that's 0, 0. We were doing that
Okay.
from C.
Oh,
That's
that's
the one that we wanted. So
And so
Just ignore that.
that guy is the one watch.
Oh my god. Nice. This is 0.785.
That's the area?
Or maybe it's not. I think, well, I think the bounded area. I can try to remove it.
Yeah, Enrique, that is the area. That's
Oh,
the
that
answer
is,
we got.
that's the answer? Oh, hell yeah.
Wait, I can get both. I can't get it to do
I'm
both.
ready for the
It's one or
test,
the other.
guys.
Sure.
Yeah,
What is it?
You mean the area?
It's gonna
Can
be
you
an
get
all
it to do
calculator
both?
test.
Because it'll only calculate like half via zero.
Just
It won't
start
do
charging
both.
for
Let's,
calculator rentals.
We're
It
trying
fills
to.
in.
People's
Calculate the
calculator.
area.
Hey, I'm done with my test. You want
Yeah,
it?
it only calculates the area of like that
One of the-
zero.
It doesn't give you the
Enrique, you monster.
What? How am I a monster?
Your calculator is a monster.
When my
So-
parents were gonna get me the calculator, they're like, we're not gonna get you an old calculator, we're gonna get you like a newer one. that
You're
can be
insulting
used
our
in
calculators.
That's what they said, they're like, why would you get an old calculator when you can get like a newer one?
Because
You
it
can
costs
use.
money. And it's basically.
It's
a
not
phone.
that much more for like, you can do way more stuff and it makes the SAT easier.
Really? What do you use it on?
Well, for like quadratic problems, this can like solve quadratic.
You solved them? That is cheating.
I checked my, how is
Oh
it
my
cheating?
word.
This is allowed on the SAT,
Well,
okay?
okay, they're usually, are there quadratic problems with like calculation?
There were some,
I
yeah,
can't remember what it was.
yeah.
All right, guys, let's set it up without a calculator.
Yeah, I can do the math.
No, I don't want to do it without a calculator.
No, it's crazy.
It's already approximated, so what's the point? Because the 1.18 is an approximation.
Mm-hmm. To the hundredths
Oh, that's
place.
what you were saying, 1.1. I was really confused. I was like, I'm not getting 1.2. You
What
guys
were
were
you doing?
approximating. Well, no, my calculator has, it can find the bounded integral, but I just did
You
that
just
first.
skipped the steps.
But I
Uh-huh.
didn't-
Like,
I didn't
well, it's the
find-
answer.
I didn't find like, oh, it's from 0 to.
Wait.
Okay,
Where did you find, or I guess your calculator is really different. Is there a way
Yeah,
to try and
mine's
do
really
that?
different. I push menu. and
This
then
is a
I
whole
push
new operating
6,
system.
and then I push 7 bounded area.
That does not help. Is there a way I can do that?
You asked me how I did
there is no on the TI-83, no, just on Enrique's calculator.
Wait, no, wait.
Well, that's not fun. What, they
Now,
can do-
Christopher's trying to figure out how to do it on his.
What's yours, 84?
So let's jam with this one here. Notice one little small problem is
Okay.
I have a square root function that's locked inside.
Oh, are we gonna have to do you?
Oh, bummer, there's a U substitution here. So I have this on my hands.
Gosh.
How about this? We have ourselves, I'm gonna split them off between two things because I gotta do them differently
Oh,
here.
yeah, we
So
can do
1.8, I'm gonna do this minus, right, I'm gonna split these two completely off of each other.
You have to do dy or dx. Not dx.
Oh, it's a dx, that's right. Thank you. Minus here, dx over here. This would be x to the fourth minus, because those are just power functions right there.
Those ones are easy. Now we-
Oh, boy.
Okay, but I guess it's not that bad when you folks, I mean, you split it off.
Mhm.
Okay.
Okay, u substitution is x squared plus 1. du is 2dx.
2x dx. Oh, we can do a 2 and then.
dx, thank you. Keep on forgetting my dx's here. Man, so for this one, I'm gonna have to do that. Okay, she whiz. Eli, are you still with us? Okay,
Wait, if we multiply.
so that means I have, let's see, 1/2 from 0 to 1.18.
Yeah, 1 over u times du.
Do we have to multiply both of the integrals by
No,
1/2?
Yeah, no, because I separated them out completely right here.
So,
Uh,
That one and this one I'm gonna do separate here in just a bit here.
Remind me what we're plugging into the bottom one. So when we
Say again, say
have
again?
the 1/2, when we first have the 1/2, and then we do 1,
Sure, this little 1/2 right here,
yeah.
because we need this little 2. And we don't have it in the problem itself.
Yeah.
Wait, what are we
Invented a
plugging
one.
in for X? Where did we get the 1?
Say again,
Is
say again,
that-
say again,
From the 1/2?
say again, Kate.
When we're plugging stuff into the X over the square root of X squared plus 1, what are the numbers we're plugging into there?
The X over the square root of X squared
Yeah,
plus
so
1,
then
this
you
piece?
jump down to the next.
Uh-huh.
Where,
Sure, so the U substitution is going to be X squared plus 1,
even below that, so right,
2X, 2X
right
over there.
there, or down.
That guy's the same thing as this guy.
The part just to the right of way.
Sure. So I scooted the X, this X here, I scooted it to the X, so the DX, so it's all in
Okay.
one spot. So just left a 1 on top. But this is still the square root of 2.
Oh,
Oh, yes, sorry. Now I know what you're doing. That guy, right? I scooted
Yeah.
X squared plus 1. Sorry, that was my
okay,
fault.
sorry,
No, I confused you. Sorry about
You
that.
just have to do it in 2 parts, Sadie. You just have to fill in.
No, because when I did that, it.
This
takes
is
the
getting
area and
longer.
it pulls it out. It goes until there, it doesn't cut in.
Okay, so let's see. Just to finish up, so we finish up here. Here's the graph of it. But
But maybe
1/2.
You could get another function and pull that area, that extra area that you're gonna have.
1/2 over the square root of
Track
u.
it, But
1 over square root of U, so that means it'll
It's
make
more work
us
than it's
up
worth.
to
I
negative
don't know how to
1/2
calculate that, so,
Yeah.
like,
du
what's
minus from 0 to 1.18. 0 to 1.18. We're gonna move Eli out.
that? He just put substitute u back in
Yeah, okay.
and then made it into negative 1/2, using negative 1/2 instead of 1.
So now we can take the antiderivative.
And then we could have actually taken the antiderivative 1 and just left the other one not for a little while
That's what
either,
I
right?
thought.
Because they're totally separate from each other now.
Yeah.
Let's see if I did it.
And then no,
So
we
U
have
to the adding one
square
is,
root of u
Mhm.
over 2, or I'm sorry, over 1/2. And then we're also multiplying by 1/2. So
Uh-huh.
those twos cancel out.
Cancel.
So
Okay.
then we just have square root of u.
So it's u squared.
No, but it's square root of u because it was negative 1/2 plus 1 is 1/2.
Oh, sorry.
And then we have, so square root of u, we still have x squared plus 1. You can plug that back in. Minus x to the 5th over 5 minus x squared over 2.
and that is from 0 to 1.8.
I
Okay,
don't
you
want to
guys.
evaluate that
Oh,
at 1.18. Maybe we should make that into a 1. That would be good. We already cheated.
Oh, hold on. My 1.18 and my 0 are in terms of X, not
That's why I
you.
put x back in.
X back in. So here it is, the square root of X plus 1.
These problems are kind of cool.
Kind of being the definition.
Okay,
There's, like,
Kate,
different
talk to
steps
me.
and
Keeping
they
up and
all
stuff?
connect
Just want to make sure.
together. It's so nice.
Okay.
What happened to the 1/2?
Let's see. It was,
It divided,
The
because it was
twos
divided by
cancel.
1/2, so the twos cancel.
That's interesting.
They always seem to do that.
Yeah, okay.
Well, that's the point of why we get the 1/2 in there.
Well, no, the point of the 1/2 is to make it so we put the u in there. And it's, but it, is there a coincidence that the 1/2 or the little outside things often cancel, Mr. Rangia?
see again?
Is it just a coincidence that often the things that we added in, like the 1/2 or whatever it would be, that they often cancel out in the end? Is that coincidence?
Not.
No, just because, let's see. Actually, because of when the final answer is right here, like this, right? Notice there was no 2 here anywhere to begin with, right?
So we're not gonna create.
But it's also because the power rule of 1/2 And like it became a 3 halves, right? Then a 3 would be there, but the 2 would be gone.
Oh.
So it's just a way of adding 1 to a 1/2.
But will that, I mean, for another problem, is it gonna happen always like that, that the little extra piece will disappear eventually through?
A few times, yeah, not all the time, but yeah, it'll be quite a bit of times that they'll
Okay.
happen. Okay, guys, let's see, can we plug this stuff in here? So I'm gonna try to, okay, I like zeros here. So 1.18 times itself plus 1, what would that be as far as the square root
I
goes?
don't know.
That'd be 2.39.
39, okay,
The square root. of
minus.
that.
Okay, and then plug it in 0. Square root of 0 is just gonna be 0 plus 1 is 1, so it'd be square root of 1 is 1. There we okay there. Minus sign. Oh, I like this 0 in particular because that 0 is going to cancel off the whole thing. So it's really just multiplying 1.18 into this situation.
What did you?
So,
Wait.
good.
Oh, I see, okay, never mind.
So 1.18 to the 5th power divided by 5. I'm going to just write it in, and eventually we're just going to do it by calculator. Is that okay at the end? In fact, let's get rid of this. Can we get rid of this little negative, the parenthesis itself?
Right.
I'm gonna go like this, that okay? And that's gonna become a positive, we good?
We pulled the 1 out? Where's that? I'm looking for the 1 thing.
Plug it in the 0.
Right.
Okay, on your calculator, all yours, can you set this up? The square root of 2.39 minus 1 minus 1.18 to the 5th divided by 5 plus 1.1. Oh, we distribute to the negative here and then the negative there.
Okay.
The only reason why that worked well is because we had a 0. We good?
Wait, I missed.
And so we're approximating it. So I guess we should put in approximation like this.
I kind of kept them separate. Once I took well, yeah, even when I took the antiderivative, I just kind of put the two functions together again. Is that okay?
Sure, yeah, you can, absolutely.
Wait, no.
7, 8,
I
4, 5,
Perfect, okay. 0.7
4, 6.
846 is
Is that what you
coolio.
got, Enrique?
Wait, 0 point.
On my,
On your stupid calculator?
it's not stupid, it's very smart, and yes, that is what I got.
Oh.
Okay, are we good there?
Hold up, so that's minus 1. Oh, so that's because you distributed the negative. Yeah.
Distribute the negative.
And then he has the minus 1 at the end because of the 0.
But if you distributed the negative,
It's still not,
negative.
wouldn't it be negative? Because
I think you did
the
the problem wrong.
1.18 to the 5th divided by 5 plus 1.18 to the 2nd divided by 2 would be bigger than the square root of 2.39 divided by 1.
I don't think so. If you plug it in to the 5th power, that's going to become a positive value. Subtract that, and then you're going to negate all of that.
Why are you subtracting that?
If-
You've already distributed.
You subtract the whole thing, which means you end up adding something.
Exactly. You just added.
So what
You don't, you just distributed. Why are you subtracting?
he has to subtract the first part.
Yeah, but it's still subtracting, which it would make the whole thing a negative in the first place, because the second part is bigger than the first part.
I don't think so, because when you take the powers of just 1.18,
X to the 5th is bigger. Wait,
Chris, will you try it the other way? We're out of time here. I didn't get to example 3. Let's see, 4, 5, and 6.
No,
Oh,
no,
it's-
video.
So I'm going to do a quick video for you guys today
Wait, did I do it wrong
sometime.
on my calculator? I'm
Finish it off.
I did it on my calculator, same thing as Kate. When you put it in.
When I put it in what Mr. Hanji did, I get it right, but I didn't do that, and so I got it wrong at first. On my calculator got it right, so you know what?
My calculator.
Eli, I'm gonna stop so Ms. Bear can set up her
Someone asked
class.
about your
Cool.
calculator.
Thank you.
Absolutely. I'll send the video of the last three sometime tonight.
Smarter than me, it did the problem right, and I did it
Cool.
wrong.
All right. Have a good day,
Is it
man.
really smarter than you?
You too.
All right.
Can
Thanks.
it understand, can
Wait.
it explain why it's doing something?